Lesson 35 is on similar and congruent polygons. And what we talked about in class is that for a polygon to be similar to another one, the sides have to be proportional. And the angles are equal. And we'll do some problems about that later. Mr. Connors drives his car 11 miles each day to and from work. Is the distance Mr. Connors drives commuting to work proportional to the number of days he works? How do you know? So if we make a little table, we say days and miles, then if one day has gone by, he's driven 11 miles, because each day he drives 11 miles. If 2 days have gone by, he drives 22 miles, because 11 the first day, 11 the next day is 22. 3 days, 33 total miles. So if we look to see if they're proportional, we can set up two ratios. Let's say one on day 1 and one on day 3. We would have a ratio of 1 day per 11 miles. And then we'd have the second ratio of 3 days per 33 miles. And the question is, are those equal? If they are, then it's proportional. So 1 times 3 is 3, and 11 times 3 is 3. So since they're multiplied by the same number, they are proportional. So yes, the ratios of days to miles are equal. If a number cube is rolled, what is the probability of rolling a prime number? So on a number cube, meaning a die, you have the numbers 1, 2, 3, 4, 5, and 6. And of those numbers, the number 2, 3, and 5 are prime numbers. So we have 6 total options because there's numbers 1 through 6, and 3 of them are prime. So the probability of rolling a prime is 3 out of 6, which would reduce to 1/2. 3 is half of 6. Adam worked 8 hours per week before his workload was increased. After the increase, he worked 4 hours per day for 6 days each week. How many more hours per week did he work after the increase than he worked before the increase? So before is 8. After is 4 hours per day, and then 6 days per week. So if we multiply 4 and 6, we get 24 hours per week. And remember, before we were doing 8 hours per week. So 24 minus 8 is 16 more hours per week. "100 residents of the city were randomly selected for a survey regarding the new gymnasium design. 32 residents approved design A, 85 residents approved design B. Use these experimental results to calculate the probability that any city resident selected at random would approve of design A." So we look and we say, okay, how many people approved of design A? That was 32. And then how many total people were surveyed? 100. Both 32 and 100 can be divided by 4. Sorry. 32 divided by 4 is 8. 100 divided by 4 is 25. So the probability of A is 8 out of 25. Then calculate the probability of B. Well, there were 85 residents that liked design B out of 100 that were surveyed. And both of those can be divided by 5 to start. 85 divided by 5 is 17. And 100 divided by 5 is 20. So the probability of B is 17 out of 20. So based on the results of the survey, which design would you recommend? Well, more people approved of design B out of the 100 than design A, so we would recommend B. 5 says expand, then collect like terms. So the first thing, expand, means use the distributive property and multiply the 3 through. Remember to multiply the 3 by all the things inside the parentheses. So we have 3 times x, which is 3x, and then 3 times 2, which is 6. And we still have the plus x plus 2, which we haven't dealt with. Collect like terms means find things that are the same, have the same variable, and the same exponent on the variable. So both 3x and x have just an x with a number. So if I have 3 x's and 1 more x, I have 4 x's total. And then 6 and 2, both of those don't have a variable, so I can add those together. 6 plus 2 is 8. So that's our final answer to simplify that initial equation. Plot these points, then draw segments to form a triangle. So 0, 0, 4, 0 means go to the right 4 and not up or down. And then 0, 3 means don't go left or right and then go up 3. So these are the points, we connect them and we form a triangle. And this side has a side of 3, and this side has a length of 4. And it says use the Pythagorean theorem to find the length of the hypotenuse, which is c squared, or c in the equation. So a squared we'll call a is 3. 3 squared plus 16, or plus 4 squared. Getting a step ahead of myself. 3 squared is 9. See ya. 4 squared is 16. 9 plus 16 is 25. And then if c squared is 25, then c must be whatever number times itself gives us 25, or the square root of 25, which is 5. So we can replace this c with a 5 now. And then what is the perimeter and the area of the triangle? So to find the perimeter, we add up all the sides. 3 plus 4 is 7, plus 5 is 12. And we don't know what the units are, so we just call them units. And then the area of a triangle, we take 1/2 of the base times the height. Whoops, not the base again. So 1/2 times 4 times 3. Half of 4 is 2. 2 times 3 is 6. And then area, again, we don't know what the units are, so we call them units. And since it's area, it's squared. And this triangle is a 3, 4, 5 triangle. It is a Pythagorean triple. It's one that would be good to commit to memory. It's pretty easy to remember because it's 3, 4, 5. And then we would not have had to do all of the work here with the Pythagorean theorem to figure out that the hypotenuse was 5. Find the area and perimeter of the triangle. Now again, we could go all the way through and solve with the Pythagorean theorem. And so if that's the case, we would say a squared, which we'll call 8. 8 squared plus b squared we'll call 6 is c squared. 8 squared is 64. 6 squared is 36. 64 and 36 is 100. And then the square root of 100 is 10. So that makes this one 10. But if you also notice, 6 and 8 are just 2 times 3. And then 2 times 4. So this triangle is twice the size of the triangle that we just did, the 3, 4, 5 triangle. So if this would be 2 times 5 then would give us 10. So again, either way, we're going to get 10 centimeters. So the area, 1/2 the base, 6 times the height, 8. Half of 6 is 3. 3 times 8 is 24. And since we're talking about area, it's centimeters squared. And then the perimeter, add up all the sides. 6 plus 8 is 14, plus 10 is 24. And then this one is centimeters. And then we're going to simplify. In the first one, we have -3 plus -15. They have the same sign, so we add just the numbers. 3 plus 15 is 18. And we keep the sign that they had, so it's -18. And then we have -3 minus -15. And the trick for when we're subtracting integers is to add the opposite. So we're going to add the opposite of -15, which is +15. And when we add things of different signs, we subtract. So 15 minus 3 is 12. And then we keep the sign on the bigger number, which is 15, which is positive. So this is +12. And number 9, we have -15 plus -3. So -15 plus -3, they have the same sign. So we add them. 15 plus 3 is 18 again, and they're both negative. So it's -18. And then we have -15 minus -3. We're going to add the opposite of -3, which is +3. And they're different signs, so we would subtract. 15 minus 3 is 12. And the sign on the bigger number 15 this time is negative. So this one is -12. 1 2/3 plus 2 3/4. Well, if I'm going to do 2/3, I'm going to write that as something over 12. And then I'm going to write 3/4 as something over 12. Oops. So to go from 3 to 12, I multiply by 4. Got to do that on the top. 2 times 4 is 8. To go from 4 to 12, I multiply by 3. Got to do that on the top. 3 times 3 is 9. So this problem then turns into 1 plus 2 I'm going to do already. 1 plus 2 is 3. And then I have 8/12 plus 9/12. 8/12 plus 9/12 is 17/12. And 17/12 is 1 whole with 5/12 left over. So we're going to have 1 more onto the 3, which is 4, and then 5/12 left over. Then we have 1/8 plus 7/8 divided by 7/8. So one thing to recognize here is when you divide something by itself, you always get 1. So that would be a shortcut here. So this right here should equal 1 when we're done, and we can test it out by doing what you actually do when you divide fractions. And you say 1/8 plus 7/8, and then you multiply by the reciprocal, which is 8/7. And then we have 1/8 plus 56 over 56, and 56 over 56 is 1. Just like what we said. And then 1/8 plus 1 is 1 and 1/8. Nine tenths minus 2/3 times 3/5. One thing that would make this easy is to recognize we have those 3's diagonal from each other, and we can divide them by 3 to begin with, so we don't have to in the end. 3 divided by 3 in both cases will give us 1. And then we do the multiplication first. 2 times 1 is 2. 1 times 5 is 5. And then I'm going to rewrite 2/5 as something over 10. I go from 5 to 10 by multiplying by 2. 2 times 2 is 4. So then I have 9/10 minus 4/10. 9 minus 4 is 5. 10 stays the same. 5/10 is half. Number 13, we have 2.54 plus 1.21 divided by 0.03. And when I have things like this being divided or as a fraction, I first do the top, then I do the bottom, and then I do the division. So the first thing I'm going to do is 2.5, I'm going to put that down a little bit, 2.54, whoops, 2.54 plus 1.21, 573, bring the decimal down. So I have 3.75 or 0.03, and the fraction means to divide. So I have 3.75 divided by 0.03, and when I divide by a fraction, or a decimal, I need to move the decimal point of the divisor until it's no longer a decimal. And however many places I move it, I move that of the other number as well. So now my new problem becomes 3 on the outside and 375 on the inside. 3 goes into 3 once. 1 times 3 is 3. Bring the 7 down. 3 goes into 7 twice. 2 times 3 is 6. Bring the 5 down. 3 goes into 15 5 times. And then I'd have 15. 5 times 3 is 15. Since I have 0 here and no more numbers up here, that's my final answer. Number 14, 7 squared minus 4, and then in parentheses 7 plus 3 plus 1 to the 20th minus the square root of 64. So the first thing that you do is parentheses, according to Please Excuse My Dear Aunt Sally. So we'll do this stuff first. So we would have 7 squared minus 4 times 7 plus 3 is 10, plus 1 to the 20th minus the square root of 64. The next one is exponents, and that includes roots. So I would do 7 squared is 49 minus 4 times 10 plus 1 to any power is still 1, because it doesn't matter how many times you multiply 1 by itself, you still get 1. And this should be a 4, and then minus the square root of 64, which is 8. After exponents, we do multiplication and division. And so we'll do 4 times 10. And after we've done all the multiplication and division, we add and subtract from left to right. So we would do 49 minus 40, which is 9, plus 1, which is 10, minus 8, which is 2. Then we have 0.3 squared minus 0.2 squared minus, and then in parentheses, 0.3 minus 0.2 squared. So first thing that we need to do is the things that are in parentheses. So I'm going to start over on the left-hand side. So 0.3 squared is 3 times 3, which is 9, but they're really 0.3, so I have 2 decimal places, so I go 1, 2 places over. So 0.3 squared is 0.09. And then 0.2 squared, 2 times 2 is 4, but they're really point and point, so I've ignored 2 decimal places. So 1, 2 places over, so it's really 0.04. And then 0.3 minus 0.2 is 0.1. So now I'm going to do the inside parentheses here. 0.09 plus 0.04 is 0.13. So I have then 0.1 squared is 1 times 1, which is 1, but they're really 0.1 and 0.1, so I've ignored 2 decimal places. So I move it over twice. So that's 0.01. And then 0.13 minus 0.01 is 0.12. Find the missing exponent. When I multiply things with the same base, I add the exponents. So this is going to be 5 plus 6, which is 11. And when I divide things, I subtract the exponents. So this will be 5 minus 2, which is 3. Triangles ABE and ACD are similar. So ABE, ABE, and then the other triangle is ACD. Okay? So which side of ABE corresponds with side CD? So this is the side we're looking at in CD. Which side looks like it would correspond? Well, this side right here. So BE. And then remember that we said that angles that are corresponding, meaning they would line up, are equal if they're similar. So if I'm looking at ABE, this angle right here in the blue triangle, says compare that with this angle in the red triangle. Well, if these two sides here are corresponding, that means that these two angles are corresponding. And so those angles have to be equal. For problems 18 and 19, refer to the spinner. It is divided into 5 congruent sectors. What is the ratio of even numbers to odd numbers on the spinner? Well, even numbers are 2 and 4. Odd numbers are 1, 3, and 5. So even numbers, there are 2. To odd numbers, there are 3. What is the probability of spinning an even number? So now we look at, there are 2 even numbers out of 5 possible numbers. So remember, probability is how many of that there are out of how many total. What is the probability of not spinning an even number? Well, that would mean you spin an odd number, and there are 3 odd numbers out of 5 total numbers. If a coin is tossed once and the spinner is spun once, what is the sample space of the experiment? So the first thing that we do is we flip a coin, and the options for that are either heads or tails. The second thing that we do is we spin the spinner. And so the options on that are 1, 2, 3, 4, or 5. So I can either get heads and a 1, heads and a 2, heads and a 3, heads and 4, heads and 5, or tails and 1, tails and 2, tails and 3, tails and 4, tails and 5. So the sample space is all of those things listed together with the squiggly brackets. So we have heads 1, heads 2, heads 3, heads 4, heads 5, tails 1, tails 2, tails 3, tails 4, and tails 5. What is the probability of getting heads and an even number? So if we go back through and we say, okay, I got to get heads, which would eliminate this entire row, and it has to be an even number. Well, 1's not even, heads isn't even, or 3 isn't even, and 5 isn't even. So there are 2 that work, and there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 total possibilities. So the probability is 2 out of 10, which is 1/5. Divide the top and the bottom by 2. Write 1/8 as a decimal and a percent. Well, to write 1/8 as a decimal, I can divide 1 by 8. 8 can't go into 1, so I add my decimal point. How many times does 8 go into 10? Once. 1 times 8 is 8. Add a 0, bring it down. 8 goes into 20 2 times. 2 times 8 is 16. Add a 0, bring it down. 8 goes into 40 5 times. And since I end up with 0, I don't have to add another 0. So as a decimal, 1/8 is 0.125. And then as a percent, I just move that decimal point over 2 places. So it'll be 12.5%. Which of the 3 forms would be most convenient to use to find a part of 4 inches? And I would say that the fraction form is easiest, because 1/8 of 4 means 1/8 times 4, which is 4 over 1, and 4 and 8 gives me 1/2. So it's easier to do mentally. For problems 21 through 20, use inspection to find all values of x which make the equations true. So if the absolute value of x is 4, then x could be either -4 or +4. because negative 4 has an absolute value of 4, and positive 4 has an absolute value of 4. In 22, 2 times a number plus 5 gives me 29. Well, what number plus 5 gives me 29? That'd be 24. So this number right here has to be 24. So now the question is, 2 times what number gives me 24? That would be 12. So we check it. We're going to do 2 times 12 plus 5. 2 times 12 is 24, plus 5 is 29. So that works. And then we look at 23, we have a proportion. There's 2 ways to solve it. One way is to look and see, okay, how do they go from one side to the other here? To go from 3 to 12, I multiply by 4. And so to go from here to here, I must have multiplied by 4. So what number times 4 gives me 20? That number is 5. The other way that you could do it is you could cross multiply, and you would do 3 times 20 divided by 12. 3 times 20 is 60. 60 divided by 12 is 5. And then there's another way to solve proportions like number 24 here has. We can look at the relationship within the fraction, and we can say, well, 7 times 4 gives me 28, so this number times 4 has to give me what x is. So x is 9 times 4, which is 36. And we can check that with cross multiplying, so it would be 9 times 28, 72, 18, 25, oops, so 252, and then 252 divided by 7. 7 goes into 25 3 times. 3 times 7 is 21. 42. 7 goes into 42 6 times. So we still get 36 by cross multiplying and dividing as well. Use prime factorization to reduce 144 over 360. So first thing we have to do is figure out what the prime factorization of those two things are. 144 is 12 times 12. 12 is 2 times 6. And 6 is 2 times 3. So we could rewrite 144 as 1, 2, 3, 4 times 2 times 3 and 3. And then we would do 360 the same way. 360 is 36 times 10. 36 is 9 and 4. 10 is 5 and 2. 9 is 3 and 3. 4 is 2 and 2. So 360 is 2 times 2 times 2 times 3 times 3 times 5. So we have things that are the same on the top and the bottom cancel out. So we have 2 and 2, 2 and 2, 2 and 2, 3 and 3, and 3 and 3. So the things that are left are a 2 on top and a 5 on the bottom. On a number line, graph the negative integers. So again, negative integers could continue infinitely, but if we have a number line here, here's positive over here, negative over here, The negative integers would be on this side, exactly on the lines, because integers are whole numbers. And my smartboard's a little off, so that doesn't look like they're exactly on the lines, but they should be. 27 says estimate. So we have 39 times 1.9. I would round 39 to 40. 1.9 to 2. 1.1 to 1. And 8.89 to 9. 40 times 2 is 80, plus 1 is 81. And 81 divided by 9 is 9. The floor of Memorial Arena measures 100 feet wide by 200 feet long. The facility is used for arena football games, which are played on a similar rectangular field that is 150 feet long. What is the width of the football field? So our first rectangle is Memorial Arena, and it is 100 feet wide and 200 feet long. This is Memorial Arena. And then the football games are played on a similar rectangle. And it's 150 feet long, and we want to know how wide is it. So we can set up a proportion. So we have Memorial Arena is 100 wide by 200 long. And then we have the football field, which is, we're not sure how wide, and 150 long. So we can cross multiply and divide. So we would have 100 times 150 divided by 200. 100 times 150 would be 15 with 3 zeros at the end. And then we would divide that by 200. So we can knock off those zeros. So 150 divided by 2 is 75. What is the perimeter of the football field then? We just add up all the sides. So we'd have 75, 150, 75, and 150. 150 and 150 is 300, and 75 is another 150, so we would have 450 feet. One sheet of paper in a notebook is 8.5 by 11 inches. A smaller notebook has a similar shape, and its pages are 5.5 inches long. So we have one is 8.5 inches by 11 inches, and another one is 5.5, and we're not sure how wide. So again, we can set up a proportion. Inches. Another thing that we could say is, well, to go from this side to this side, I multiply by 2, because 5.5 times 2 gives me 11. So this number times 2 must give me 8. So what number times 2 gives me 8.5? So that would be 4 1/4. And we could set up the proportion. We would just have 8.5 over 11 equals question mark over 5.5. And we would multiply 8.5 times 5.5 and then we divide it by 11. And we should get 4 1/4 or 4.25. Triangle PQR is isosceles and angle PRS measures 130 degrees. Find PRQ, so this angle right here. Since PRQ here and PRS here make up an entire half turn, that's 180 degrees, 130 of which are taken up by PRS. So PRQ is 180 degrees minus angle PRS, which is 130, which is 50 degrees. Angle Q, if it's isosceles, has to equal angle RQ, because these two sides are equal by the tick marks here. So these two angles must be equal as well. So this one also would have to be 50 degrees. And then angle P comes from 180 degrees total in the triangle, minus 50 from angle Q, minus 50 from angle PRQ. 50 and 50 is 100, so that leaves 80 degrees.